Hi guys, I'm Sanjeev. This project is on identification of genes through the Bayesian elastic net model. So what's the big picture? We know that the person is down with the flu, so we find the genes responsible for the symptoms that are shown because of the flu. This is a subset of one of the problems in the respiratory viral dream challenge. The parameters of H3N2 and H1N1 samples were available in the unrestricted access section. Since symptoms are almost always observed after a period of time, for this experiment, we consider the readings at 93.5, 101 and 105 hours after inoculation. Training is done with influenza A data and testing is done with the swine flu data to observe the correlation between the genes. So in order to understand and analyze such gene expression data, we use linear regression of the form y is equal to x beta plus epsilon, beta being a regression coefficient vector and epsilon is the model error or the additive noise. Beta is the p number of genes cross one vector and epsilon is n number of samples cross one vector. So the main interest here is to estimate beta for a model. Lasso has been proposed to address the feature selection problem by imposing a sparseness constraint on the regression coefficients. So the objective function is given by that, and the L2 norm in the first term accounts for prediction accuracy while the L1 penalty term yields a sparse solution. Though Lasso is pretty successful, however, if some relevant features are highly correlated with each other, Lasso tends to arbitrarily select only few of these, ignoring the rest. So we need a more flexible or elastic model given by the Bayesian elastic network, whose argument is that the final estimator is defined as a rescaled version of the solution of the Lasso, what we just saw. The combination of L1 and L2 penalties make the optimization problem strictly convex, and the lambdas are the two parameters to be tuned via cross-validation, and lambda 1 can be removed analytically. From a Bayesian viewpoint, the lasso can be interpreted as a maximum a posteriori estimator with Laplace priors placed independently on the components of beta given by this can be viewed as a product of Gaussian and inverse gamma distribution Here tau is the precision of the additive noise. Go back to the equation of regression where epsilon serves as the model error and tau does the same purpose here, and alpha j is the latent precision parameter for beta. So the complete Bayesian lasso model can be expressed as y being a Gaussian distribution with mean x beta and covariance tau inverse, beta again a Gaussian with zero mean and covariance tau inverse and alpha inverse, tau is a gamma distribution, alpha and gamma given by inverse gamma with gamma priors imposed on it. We typically choose A0, B0, C0, D0 as 10 raised to minus 6, so this gives non-informative gamma priors. So the full likelihood of the Bayesian lasso becomes the product of that, and that. Let's extend this to the elastic net configuration, which is a combination of lasso and it incorporates the idea of grouped variable selection. Let me just copy paste the initial lasso parameters and write the main equation. The tau term gets an additional lambda and the alpha term gets another constant and the extra lambda term. Notice that when the lambda 2 term becomes 0, the whole thing goes back to the lasso model. So the complete likelihood of the model is once again given by the product of the parameters. We have the Gaussian y, the gamma tau, we have the priors beta, and the alpha with the imposed gamma. Sorry, this derivation was done at a rocket speed. I recorded this initially for about 15 minutes and I'm playing this at 4x speed. So I suggest you reduce the speed when you revisit. Time constraints, you see. So once the training and testing is done, we get the top 50 genes with the test set error of 7%. The ECEN diagram with the path taken by the shrinkage coefficients are shown. So we use this method over lasso because it gives correlation between the genes which was missing in lasso. So the main goal was to develop a diagnostic tool for distinguishing those individuals with symptoms and those without. So we need the pathways which are given by the genes to infer the required diagnostics and treatment. Um, so that's it. Thank you very much for your time. Uh, Please feel free to post any questions on Piazza. Have a good evening.